Okay, so this video is dedicated to the next class that I designed for simulating these combinatorial events. This time simulating permutations, which is significantly harder than the Cartesian product. To begin with, right, this is going to have slightly different inputs. For one thing, you're going to input a single set, right? We're going to look at having a set and taking only permutations of a certain length, which are going to be sort of rearrangements of the elements from the set within sort of like you imagine like a tuple of this fixed length. Anyway, so you input a set from which we will take the permutations and a length, which is going to be the length of the permutation that we try to generate. I save these as set and k. And what else? So I also have a current indices list, very much like the previous one, although this one sensibly is initialized to I for I in range length, which is to say that it's going to be 0 and then 1 and then 2 and so on, representing that I take the 0th item from the set and then the first item, right? Because I mean, these are permutations. You take them without replacement. So you have, right? You couldn't take 0, 0, 0. It wouldn't make any sense for a permutation. So we take 0, 1, 2, and so on without replacement. And again, I have a tracker for whether or not the end has been reached. The next thing to talk about is this step next index method. And it takes no arguments, right? So the entire point of this is to take whatever the current index is and sort of define a notion of which one is the next index. Now, just for illustration purposes, it'll probably be useful to think, what if the current index is 0, 1, 2, right? What should be the next index, right, or list of indices? And, assume that, the size of the set in K are also large that, that we have plenty of space to move on to further indices. So the idea is that if you have 0, 1, 2, 3, we'd like to go to the 3 and try to increment it higher if possible, right? So I would like it to be 0, 1, 2, 4. But certainly at some point, as I keep incrementing it, it's going to basically reach the end of the set, right? Because each time I increment that index, I'm grabbing a next and a further item in the set. And at some point, right, basically when this reaches n, right, if n is the length of the set, then when my index reaches n, I've gone too far. And so that would be like 0, 1, let's say 7, right? So maybe our set has 7 elements indexed 0 to 6. When that last index increments up to 7 and has gone too far, then what I'd like to do is basically to, in a sense, kind of set it all the way back down to 0, I suppose, right? But you couldn't do 0 because 0 is already taken. But in any case, right, the basic methodology is going to be to say, okay, so since it's gone too far, let me now move to the next index, peel that one off, and try to, again, right, start incrementing that. So you're going to have 0, and then it used to be 1, but now we're going to set it up to 2. And then you're going to come back to the last index and find the smallest value that it could be without taking a value that's already present. So, right, because again, we don't want repetitions. So if the first index is 0, the next one is now 2, then we're going to set the last one down to 0, but then see that that's already taken, so we have to immediately shift it up to 1. And then we see that we've got 0 to 1, that's safe. So that's the next one in that stage. Okay, great. Just to describe it, a few more steps, just in case this is helpful. The next time we call next, I'm going to take that, right, it's 0 to 1, I'm going to take that 1, try to increment it up to 2, but I see that 2 is already taken, so I can't have 2. I have to move it up to 3. 3 is not taken, so I land at 0, 2, 3. And to describe it a little bit more, so I keep incrementing 3, eventually 3 becomes 7, and so I peel off the 2, right? So now I've, what used to be 0, 2, I've now exhausted everything. I peel off the 2, and I set the 2 to the next available value, which is 3. 3 is not taken because the only other thing is 0. So 3 is acceptable for that coordinate. I come back and I try to set the final coordinate back down to 0, but 0 is already taken. So I move it to 1. 1 is not taken, and so on. Okay, I hope that description explains the sort of mental image about how these indices are incrementing. Because I'm doing a lot of mutating things in place, then I really would like to have this copy of the current index list. And this is just for an abbreviation, right? N is the length of the set, so anyway, and then this last, right? So last, what am I doing? I'm taking the current index list and I am popping, which is to say I take the final element and I remove it, and I also increment it by 1, and I store that as last. So last is effectively going to be looking at, in a sense, the index that I'd like to put at the end of the current index list, right? Because I popped it off, so right now CI at that point, CI, the current index list, has one too few elements. And so last is the thing that I'm going to try to tack onto it if I can. But I always have to make sure that when I tack something onto it, it's not too large, right? It can't be N. And it also can't be something that's already in CI. Okay, so while the length of CI is too short, right, because K is the length that it needs to be, so long as it's too short and I'm still looking for a next thing to put onto it, I check to see whether or not last is within the acceptable range, that is to say less than N. If it is, I then need to check to make sure that whatever last is not something already in the earlier portion of CI. If it's not, then that's great. I just tack it on and I set last back down to 0. That part is really for like the next time, right? Like basically the next time I go through this loop, right? So if you imagine, as I was describing just a minute ago, where you are at the state where you had 0 figured out as the leftmost coordinate index, and you peel off like 1 for the next part, because it used to be 0, 1 something. We're peeling off that 1, we're bumping it up. We see that when I set it to 2, that's acceptable, so now I've got 0, 2, but I now want to go to the next index because that's not yet resolved. And I want to set that one all the way back down to 0 and kind of go through this all over again, because I am going to find that then 0 is already taken, so I need to bump it back up to 1. Anyway, so this setting last back down to 0 is getting me ready for the next go through the loop for when I look at the next coordinate. But anyway, okay. Now, what's happening here is that I am basically saying that last was small enough, but it was also already taken in the current index list. So I just need to increment to the next thing and then check it. So I just increment it to the next thing, and then the loop is going to happen all over again, so that I sort of continue seeing whether or not that increment is acceptable. Now, what's happening here, this is the scenario where last was equal to N, which means that I have exhausted this index. I can't set it up anymore, so I need to peel off the next index on what is currently stored in CI. Now, if CI is the empty list, there is nothing to peel off. That means that I can't go any further. I've exhausted the whole thing. So I set end reach to true and break out of the loop. But if there is room to pop something off, then I pop off and I add 1. That's my new value of last, and CI has been shrunk in size by 1, right? I've cut the final element out of it. So anyway, Hopefully, right, and at the very end, I reassign, right, whatever is the resulting CI is what I assign to the current index list. And so hopefully that makes clear what this step next index does. And just to be explicit about this, it only reassigns the current index, but it doesn't actually grab you. I don't. It doesn't like return anything, I guess I should say. So that's going to take place in the next method. Okay, so the next method, having gone through all that work, that was really the heavy lifting. So the next method is quite simple. It's got an input property just like in the previous class. And all I'm going to do is say, as long as I have more to explore, right, as long as the end has not been reached, then I am going to use the indices to get the elements from the set, right? So I'm priming an output so that I can return it if it satisfies the property, right? So I'm saving that for now so that later on I will, if it has the property, I will return it, and otherwise I will return none. But before I check it for returning, I'd like to prime the index, right? I'd like to step the index to the next available one so that on the next call, I can sort of store that value into the output. So I always want the index primed to be ready to shift the, so collect the output that I want, right? So the current index should always be storing the indices of the thing that I am like going to return as soon as next is called. Anyway, so you always prime it for the next call to next. And if it doesn't have the property, then, and if you reach the end, then I return none. And of course, reset is very straightforward.